And we have our log properties inside of the logarithm. Multiplication will become 2 logs, division becomes 2 logs subtracted, and our powers become coefficients. So an example of using log properties is if you were given that the natural log is equal to 2 and the natural log of 5, or excuse me, natural log of 2 is equal to 0.6931, natural log of 5 is this 1.6094, what we can then do is we can use that to find natural log of 40. And the key thing is if you look at the arguments that you've been given 2 and 5. And so what you want to do with those given arguments is you want to take 40 and write it as a product of what the given arguments are. So in this case, 2 and 5. So what you would do is you would draw a little factor tree. You might say, okay, I have 8 and 5 here. 8 is 2 times 2 times 2, and then times 5. Now, there's 2 ways of approaching this problem. One way is you could just say, I have natural log of 40, which is the same thing as inside of the argument as 2 times 2 times 2 times 5. And then you could say, okay, I have multiplication inside of this argument, so that becomes natural log of 2 plus another natural log of 2 plus another natural log of 2 plus natural log of 5. Now, if you notice what you're really working with here, you are working with 3 natural log of 2. And you would get that if you had thought instead about looking at this as natural log of 2 to the third times 5. Because in that case, what you would get is you would get a natural log of 2, and then you would bring down the power of 3 plus natural log of 5. All right, so again, let's just focus on one method and one method only. So yes, you could bring down the power, think about it as 2 to the third, or what you can do is you can just think about it as natural log of 2 3 times, and then plus the natural log of 5. So what you would do after you use your log properties is you would then plug in what the known quantity is for natural log of 2. So you would plug in that natural log of 2 is 0.6931 plus another 0.6931 plus another 0.6931 plus the natural log of 5 as 1.6094. And then you would simply compute that number. And when you compute this, you will get 3.6887. And again, whether you break it up into 3 little natural logs of 2, or if you use your powers, you're going to get to the same conclusion of the 3.6887. Okay? All right, so let's look at one more here. If we have natural log of 5 over 8, again, the same idea, what we would want to do is we would want to break up the 5 and the 8 in terms of what is given to us, 2 and 5. So to do that, we would have natural log, and again, the 5 is already broken up for us in a known logarithm, and then the 8 we would factor as 2 times 2 times 2. Now, you need to be careful here, because what is happening with our log property is this division is going to become subtraction, but it's not going to just be subtraction of natural log of 2. All of the denominator needs to be subtracted. So it's going to be minus and then all of the denominator broken up. Now, when we split up the denominator here, because we have multiplication inside of the denominator, this will become natural log of 2 plus natural log of 2 plus natural log of 2. So again, this subtraction here is coming from numerator minus denominator. But then all of these plus 2's are coming from the fact that you have 2 times 2 times 2 inside of that denominator argument. So when you compute this, what you'll need to do is you'll need to take natural log of 5 and then minus all of these natural logs of 2. So we'll need to distribute the natural log of 2 to all 3 of those. Okay, and again, just like we noticed up above, this will then give us really a minus 3 natural log of 2. And so then the final step is just to substitute in what these known quantities are. So you would plug in the 1.6094 and then minus your natural log of 0.6931, minus another 0.6931, minus another 0.6931. And again, you could just write that as 3 times the 0.6931. And that is going to give you negative 0.4699. And do not be alarmed if it is a negative. That is perfectly fine. So we have a negative and that is fine. Now, one little side note I would like to make here is this natural log of 1 over 5, that becomes natural log of 1 minus natural log of 5. But you'll notice that natural log of 5 is given, but this natural log of 1 is not. And that is a known quantity that the natural log of 1 will always be 0. So that's a little bit of a trick there, but you'll just plug in the minus natural log of 5.